Alright, this time we're starting 7.4, which is the law of cosines. This is a little more difficult than the law of sines. You can see right here at the very top what you need to memorize is c squared is equal to a squared plus b squared minus 2ab times the cosine of c. A, B, and C are the side lengths. Cosine C, of course, will be an angle measure. Then if you know a squared, these are also law of cosines, right here and right here. A squared is equal to c squared plus b squared minus 2cb cosine A. So if you can see a pattern, when you're looking for c squared, you use a and b and subtract 2 times those same two sides, and then times the cosine of the angle you're looking for. A squared will be, you'll do c squared plus b squared minus 2 times those same two sides, times the cosine of A, which is the angle you're looking for, or the side you're looking for. B squared, A, use A and C, minus 2AC, and then cosine of B. So it follows a pattern. You just have to kind of remember it. The law of cosines can be used to solve triangle problems when you know the two sides and the angle between them, or you know all three sides and none of the angles. Okay? Or you know all three sides. All right, let's look at the law of cosine. Again, what you're going to do is you're going to label your triangle, draw it. So this time we have to draw a triangle. So we have A, B, and C. We've got 35 degrees. Okay? And we've got A is 5, so that's over here. And we've got C is 6, across from C. And we want to just now to find B. They don't give us find everything, just find B. Okay? So this is the one we're looking for. So if we want to find B squared, we need cosine of B, which we have. So that's good. And we know the other two sides. So this one's pretty straightforward. You look up there and you say b squared is equal to a squared plus c squared minus 2ac, again it's the sides we just used, times the cosine of b, which is the angle we know. So b squared is going to be a squared, which is 5 squared, plus c squared, which is 6 squared, minus 2 times 5 times 6, times the cosine, and the angle B is 35 degrees, so that's cosine of 35. Again, be sure you're in degrees. Okay. Now, when I multiply all these things together here, all of this, 5 times 6 is 30, so that's 60 times the cosine of 35. And that's going to be a number. And 5 squared plus 6 squared, that's 25 plus 36, and that's going to be 61. Okay? So then when we find all that, we're going to have to take the square root of all that for B. So B is going to be the square root of 61 minus 60 cosine of 35. And when we do all that math, and you should take the time to do it, B is equal to 3.443. So we have successfully found side length B. Now we're going to do example 2. Example 2, again, given triangle ABC. Okay, let's fill in what we know. A is 6, which is across from A. B is 5, across from B. C is 7. Okay. and we want to find angle C right here. That's what we want to know. Okay, so if you look up at the top, the one that has the angle in it, angle C in it, is the example where we find the side C squared. So what you're going to have is you're going to use the C squared is equal to A squared plus B squared minus 2AB cosine times the cosine of C. Now let's fill in the blanks. So C is 7, so that's 7 squared is equal to 6 squared plus B squared is 5, so that, or B is 5, so that's B squared minus 2 times 6 times 5 times the cosine of C. Okay, so 49 is equal to 36 plus 25 minus 30 times 2 is 60 times the cosine of C. Okay, now we can bring over, we have 49 minus 36 minus 25. That's going to be negative 12 equals negative 60 cosine of C. Okay, so since they're both negative, the cosine C is equal to negative 12 over negative 60, or positive 12 over 60. And then you're going to have to type in, because we're finding an angle, we've got to go up here. I'll get up a little bit off the bottom. You're going to have to do the cosine negative 1 of C, 12/60ths, if you want to put that in. You could put in 1/5, and that's going to give you your angle measure, which is 78 degrees. And so angle C is 78 degrees. So again, when you're finding the angle, you're going to have to end up going back and doing that second sign or arc sign to find the angle. So don't forget that you have to do that. When you find an aside, it's a little different than finding an angle. Right, let's go on to our next page. Now this has a little information. It's easier to use. Obviously, the law of sines is a lot easier formula than the law of cosine formula. But they're still just formulas, and you can plug stuff in. It's not rocket science. I mean, you match up what you need, you look at what you have, and you look at what you need, and you find one of these problems or one of these formulas that works. Once you've found an angle and its opposite side with the law of cosines, then you're free to go back and use the law of sines. The math is a little easier. However, and this is critical, the law of sines cannot be used right here to find an obtuse angle. So if you think there's a possibility the angle you're looking for will be obtuse, then don't use the law of sines. Okay? And remember, this is critical too, the largest angle in a triangle is always located opposite the longest side. So in that case, use the law of cosines to find that largest angle, and then you're probably okay to go back and use the law of sines. So in example 3, we've got to find more stuff than we did in example 1 and 2. We have to find all the angles. So first we're going to draw out our triangle, ABC, and we have side lengths 6, 12, and 15. Well, it really doesn't matter where you put them, but I'm going to say A is 6, B is 12, and C is 16. Okay. So we want the largest angle, and so that's going to be the one that's across, well, I wrote 16, sorry. That should be 15. So B is going to be our largest angle because it's across from the largest side. So we're going to find B. So we're going to say that B squared is equal to A squared plus c squared minus 2ac cosine of b. Okay? So 15 squared is going to be a squared was 6, so that's 6 squared plus 12 squared minus 2 times 6 times 12 times cosine of b. Just putting it in that formula, putting everything that we know, and so the only thing we don't know is b. All right, so 225 is equal to 36 plus 144, so that's going to be 180, minus 12 times 12 is 144, cosine b. So the cosine of c, or cosine b, excuse me, we have 225 minus 180, which is 45. You're going to subtract your 180 here. Okay, so you have 45 equals negative 144 cosine of b, and so cosine b equals 45 over negative 144. So now we have to do cosine negative 1b of, well, 45 over negative 144, and that's going to come out to be 108 degrees, obtuse. Okay, now we can go over, so we know angle C, let me go up here, angle C is 108 degrees. So now we need to find angle A. So sine, well, we're going to switch to the law of sines because it's easier. 1 over 8 over 15 equals the sine of A, which we don't know, over 6, which is side A. Okay. So 6 sine 108 over 15 is equal to the sine of A. Once you find that angle, what that value, okay, you're going to say the sine negative 1 of A, okay, if you want to put all that in, you can, or you can solve it for a number and get a number value, and that's going to equal 22 degrees. Okay, so we'll go over here, angle A is 22 degrees. And the last thing we can do then is, we know with two angles, so we just subtract from 180 to find the third. Okay, so 180 minus 108 plus 22 is going to equal angle B. So that's 130, 180 minus 130. And that equals angle B. So angle B is 50 degrees. So angle B, so there's our three angles. Angle A is 22 degrees, angle B is 50 degrees, and angle C is 108 degrees. More complicated, a little harder to solve, but you can switch back from law and cosines. But again, solve for your largest angle, and that way you'll probably avoid trying to use the law of cosines for a obtuse and obtuse angle. Okay, let's look at number 4. We've got an angle. Okay, we've got A, B, and C. A is 7, C is 9, and B is 34 degrees. Okay. So obviously we know an angle and we know two sides, and we know two sides and the angle between them. So then we can solve for that other side that we're missing. So we can solve for B right here. So B squared is the first thing we're going to do. B squared is equal to A squared plus C squared minus 2 times A times C times the cosine of B. We're looking for B squared. Okay. A is 7. C is 9 minus 2 times 7 times 9 times the cosine of 34. So all of that's going to, and then we'll take the square root of all this when we're done. Okay, so it's going to equal the square root of all that. So we have 49 plus 81, that's 130, minus 63 times 2 was 126, cosine 34. And that's just doing the squaring the 7 and the 9 and adding them together, and then multiplying 9 times 7 times 2 and getting 126. So B then, once we do all that and take the square root of it, is 5.054. Okay. Now, here's the thing. We have two sides left. One is a 9, side length of 9, and one is a side length of 7. When you solve, you're solving for angles, and you're not sure where one of them might be obtuse or not. For the second step, solve for the smallest angle, which will be from the smallest side. So my advice here then is solve for smallest angle. And again, use the law of sines, but use it for the smallest remaining angle. So that's going to be sine A, because 7 is smaller than 9. That's the other two sides that are left. So we're going to say the sine of 34, which is sine of B over B, 5.054, equals the sine of A over 7. Okay. All good there. Then you're going to have to say sine -1 of 7 sine 34 over 5.054. Again, you can work all that out and put it in, but that's what you're doing. You're going to take the arc sine of that number. And so the measure of angle A is going to be 51 degrees. Now your third step then, of course, is subtract it from those two angles from 180. So step 3, you have the measure of angle C will be 180 minus 34 plus the angle we just found, which is 51. Okay, so the measure of angle C will be 180 minus 75, which is going to be 95 degrees. So the things that we were missing were angle A and angle C. There's angle C, here's angle A, and then we already marked the side length that we were missing. It takes some thought to use this, but you can switch back and forth between the law of sines and law of cosines depending on what you know and when to use them.